Good afternoon, sir. So the topic that I picked is Lagrange's method of undeterminate multiplier. So with this method, we find the maximum and minimum values of any function such as f, x, y, z. The maximum and minimum values are also called the critical points of the functions. To find the maximum and minimum values, we need constant, that is g, x, y, and z. With the help of this, we find the maximum and minimum values of the function. In this process, we need the help of lambda 2. So we'll take a look at the steps that we have to follow during this method. So the step number 1, we have to form an auxiliary equation. The auxiliary equation is the main equation f(x,y), which consists of the function small f x, y, z plus lambda g x, y, z. So we will form the auxiliary equation. This is the first step. In second step, we will partially differentiate the auxiliary equation that we have formed in step 1 with respect to x, y, and z. And in the third step, we will equate all the four equations, that is fx is equal to 0, fy is equal to 0, and fz is equal to 0, and the constant for the Lagrange's multiplier lambda and stationary values of x, y, and z in the respectively. So we'll take a look at an example. Determinant multiplier. So I will take an example. So the example that I will pick is one number. Find the maximum value of x, y, z when x plus y plus z is equal to 15. So we have to find the maximum value of x, y, z when x plus y plus z is equal to 15. So step 1, we will write the given conditions. So given is function f x y z is equal to x, y, z. We denote it by equation number 1. The next function is g. So this is function g. This is x. This is g. G is x, y, z is equal to x plus y plus z minus 15, which is equal to 0. We denote it by equation number 2. So now we will substituting equation number yes. So from equation number 2, we got from equation number 2 we get the value of z. From equation 2 we got the value of z, that is z is equal to 15 minus x minus y. From this equation, z is equal to 15 minus x minus y. So we give this equation number 3. So now we will substitute equation number 3 in 1. So we will put the value of z in equation 1. So we will put the value of z in equation 1 in here. So if you put the value of z in equation 1, we will get, putting the value of z in equation 1. So f x y, it will be function of x and y only, since we have put the value of z in terms of x and y. So f x y is equal to x y 15 minus x minus y. This is the value of z. So now we will simplify this. So it will be 15 xy minus x square y minus x y square. So this is the function fx in terms of x and y. So now we will differentiate this. So we will differentiate the function. Okay, I will write it once again. X y is equal to 15 x y minus x square y minus x y square. So we will differentiate this function in terms of x, partial differentiation with respect to x, and partial differentiation with respect to y. So partial differentiation with respect to x, will get 15y minus 2xy minus y square, and with respect to y, you will get 15x minus x square minus 2xy. So now we will put the value of x is equal to 5, y is equal to 5, and z is equal to 5, and we will find rt minus s square. We will find rt minus s square. You have to find this. So the value of r is equal to double differentiation of f with respect to x. So this is equal to, so if we differentiate this one, once again we will get 2x, sorry, 2y minus 2y. Similarly, if we do s dx dy is equal to, we will get 15 minus 2x minus 2y. Now if you put the value of x is equal to 5, we will get 15 minus 10 minus 10 is equal to minus 5. Here also we will get minus 10. So minus 10 is less than 0, and minus 5 is also less than 0. So we will find now t. T is equal to differentiation of, double differentiation of respect to y. So we will get minus 2x is equal to minus 2. We'll put the value of x is equal to 5. So we will get minus 10, which is less than 0. So therefore rt minus x square is equal to minus 10 into minus 10 minus 5 square. Since s is, and the value of s we got as minus 5, and the value of r is minus 10 and t is minus 10. Yeah, t is this one and r is this one. So this is equal to minus 10 plus 100 minus 25. So plus 100 minus 25 is equal to 75, which is greater than 0. Therefore maximum value of x, y, z is equal to 25. Thank you. So now we will look at the second example. So in the second example, we have taken the function f x y z is the function, x y z is the main function, and the constraint we have taken is x plus y plus z minus 3 is equal to 0. We have to find the maximum value of x y z when x plus y plus z is equal to 3. So the first step, we have formed the auxiliary equation. The auxiliary equation is the main function f x y z, which is x y z plus lambda x plus y z plus z minus 3. So in the second equation, we have differentiated the main function with respect to partial differentiation with respect to x, partial differentiation with respect to y, and partial differentiation with respect to z. So with respect to x, we have got yz plus lambda. With respect to y, we have got xz plus lambda, and with respect to z, we got xy plus lambda. So in the third step, we have solved the four equation with respect to with respect to differentiation of df by dx is equal to 0, differentiation of df by dy is equal to 0 and differentiation of df by dz is equal to 0. So we have solved this equation, and we got the value x is equal to minus f by lambda, y is equal to minus f by lambda, and z is equal to minus f by lambda. We can solve this value of x, y, z through various methods. So after solving, we got the value x plus y plus z is equal to 1 and minus lambda is equal to 1. So now, since the main function is fx y z is equal to x y z and g x y z is equal to x plus y plus z minus 3, we have written with respect to z, that is z is equal to 3 minus x minus y. So after that, we have differentiate the we have written at x is equal to 1, y is equal to 1, and z is equal to 1. We have found the value of r, that is a double differentiation of f with respect to x square. So we have got minus 2, and for s we have found the differentiation with respect to y and with respect to x as well. We got minus 1. So in t it is the double differentiation of f divided by double differentiation of f with respect to y. We got the value minus 2. So we found the value of rt minus x squared, that is 3, which is greater than 0. So x is equal to 1, y is equal to 1, and z is equal to 1 is a point of maximum, and maximum value of x, y, z is equal to 1 into 1 into 1 into 1, that is 1. Thank you.